DC electricity, DC being an abbreviation for direct current. DC electricity is more the kind of power that you might find stored in batteries. It's also what is more often the electricity type utilized in automotive and mobile power systems and many lower power appliances like radios, phones, LED lamps, and battery-powered items. And mobile systems that are powered by low voltage, 13 to 14 volt alternators. Yes, that's a 13 to 14 volts. Just a little more than the nominal 12 volts that the rest of the vehicle's electric system utilizes. Truth is, a regular lead-acid automotive starter battery is charged up 100% when it can hold a voltage of 12.6 volts. When it drops down to 12.2 volts, it is then 50% depleted. You really should never deplete a regular lead-acid starter battery lower than 12.2 volts, or 50%, as a lower SOC, that is, state of charge, can be destructive to the battery's internal workings. Please look up battery sulfation if you want to know more about this. Lead-acid leisure batteries, sometimes known as deep cycle or marine leisure batteries, can go lower than 50%. However, it's always best to read what the battery manufacturer's specifications are in respects to how low you can drain the power out of a deep cycle or marine leisure battery. As it is, the alternator needs to have just a little more electrical voltage, like 13 to 14 volts, so that it can pour electricity into the lead-acid battery. The slightly lower voltage, 12.6 volt battery, it's like pouring from one container into the other container. One container will need to be a little higher than the other. Please note, just because I say lower voltage or DC, that doesn't mean that you can't get an electrical shock from it. It just means that you're probably just a little less likely to get a shock. Just because the voltage is lower, it's not altogether impossible to get a nasty electrical shock from a DC power source, so always be careful when handling anything electric. DC, unlike AC electricity that pulses, DC flows. That is, it pours through the wire, almost like the flow of water in a hose pipe. DC electricity is what is used in motor vehicle and leisure vehicle batteries. The batteries are often charged up by the motor vehicle alternator, the nominal voltage in most standard small to mid-sized vehicle applications being around 12 volts. No, when your vehicle is running and your alternator is creating power, most vehicle devices will use the power generated by the alternator and only use the battery reserve power when the engine is no longer running and the alternator is no longer generating power. A couple of notes. Charging your batteries by an alternator is not the only way to charge batteries in an automotive or leisure vehicle environment. Batteries are often charged by solar power or an AC landline attached to an onboard battery charger also. The term nominal means average. The average power a device or battery was designed to utilize and connect to. In our case, for the rest of these tutorials, we'll use the 12 volts as the nominal voltage. Something to keep in mind about DC electricity is it doesn't travel very well. That is, it will decrease or attenuate in strength and voltage the further it has to travel along a wire. One of the ways used to compensate for this loss in power by attenuation is to use a thicker or heavier gauge wire. So you should keep in mind the longer the reach of wire you use for your application, the heavier the gauge of wire you should use to maintain the strength and voltage of your wiring. The DC wiring colors are also different from AC wiring colors. In a DC circuit, there will be one wire leading from the power source out to the device and one wire coming back from the device, that being 2 wires in total. One will be a red wire, that's the live wire, sending electricity to the device. Then there will be a black wire coming back from the device to the battery, or the DC power source. On many vehicles, the metallic body of the vehicle is used as a way of carrying electricity instead of a black wire. This is referred to as a grounded vehicle. Saves on wire and can make some of the electrical wiring easier. Don't worry, is there's not enough power in this method of wiring to give anyone an electrical shock. A little note, AC electricity doesn't have the same attenuation problem or loss in power as DC electricity, and can use fairly lightweight wire over long distances. That's why AC was invented. However, AC needs more expensive and complex equipment to generate the AC power. That's why DC is used primarily for lower voltage systems. I'll explain volts and other measurements commonly used in electricity next.